Okay, hi guys. So today I'm going to do the editorial for Codeforces around 753 Division 3. So I haven't participated. I was just reading the problem set on my mobile phone, and I was able to mind solve a lot of these problems. I mean, all of these problems. So I will just be quickly explaining the solutions to these problems. But I don't have any code to show because I haven't written any code. But yeah, I can explain the basic concept of these problems. So this is the first problem, linear keyboard, in which you have a linear keyboard basically. So you have all the 26 different letters of the English language, and they are arranged in an order, and you want to type out a word. So they want to ask the total distance your finger will move while typing these words. So to do that, you just have to see the difference between the consecutive characters and find out how much you have to move to type those letters. For example, in this example, we know that H is on the position 8 and E is on the position 5 and so on. So this is just an implementation problem. Take the position of H and E and add the absolute difference between them. So in this case also you have to do the same. Assign 1 to Q, assign 2 to W, 3 to E, 4 to R and so on. So yeah, that's what we have to do here. And then just add the differences. So now we can move to the problem B, which is odd grasshopper. So in this problem, I think it was a little more complex than the third problem, but let's do them in sequence. So in this, what's happening is that we will be moving on in we will be starting from a point and we will jump a certain distance at every move, and there are 10 moves in total. So what we will be doing is that we start from the point 1, like from the point x, whatever x naught is given, and on, say for example, the seventh move we will jump seven positions. On the ninth move we will jump 9 positions. On the 11th move we will jump 11 positions, and so on. But the direction, whether we will jump left or right, is uh, determined by the coordinate at which we are currently present. So if we are on an even coordinate, then we will jump towards left. Otherwise, we will jump towards right. So depending upon the position that we are at, for example, if we are at 2, whatever distance we jump, we will jump towards left. And if we are at 3, 5, or 7 or anything, then we will jump towards right. So one thing we can notice is that odd numbers change the parity of position and even numbers don't change the parity. So that means when you are wherever you start, after you jump 1, the next step will be in the opposite direction, but the next step will be in the same direction because 2 does not change the parity, and 3 will change the parity. So 4 and 5 will be in the other direction, and then 6 and 7 will be in the other direction, and then 8 and 9 will be in the other direction. So what's happening is that whenever we do an even move, the parity does not change, so the direction does not change. But whenever we do an odd move, the parity and direction would change. So if we take 4 consecutive numbers and if we add them, we will get the value 4. You can observe this and notice that this is 4. So what will happen is that if you take the sum here, so this is like 1. If you take the sum till here, this is like 5. If you take the sum till here, this is 9, and so on, right? So whenever you are at the numbers 1, 5, 9, 13, 17, 21, and so on, the total distance that has been jumped will be exactly 1, 5, 9, 13, 17, 21, and so on. And this is the fact that we have to use to solve this problem. So whatever n is, what we will try to do is we will try to take 4k plus 1 out of it, and we know that 4k plus 1 we will be going in the same direction, and whatever 1, 2, or 3 or 0 moves that are left, those we can do manually. So this is kind of like a oven algorithm, and this way in just constant time we can find out whatever is the answer. And this 4k plus 1, whether we have to go in the left direction or in the right direction, will depend on whether this x naught is even or odd. So, yeah, so that's how we work with that. And the third problem is minimum extraction. So I think this one was easier than the second one. In this, we are given an array and we can do a certain move as many times as we want, even 0 times. So the array has to be, to perform the move, the array has to be having at least 2 or more elements. And what we will do is we will take the minimum number from the array and we will throw it out of the array, and from the remaining elements we will subtract that element from all the elements. So what will happen is that obviously one candidate of the answer is the original minimum of the array. Like whatever is the original minimum of the array, obviously that can be the answer if we do not perform any moves. But what if we perform any moves? So since we are only like we don't care about the order of the elements in this problem, then that means there is no disadvantage in sorting the array. So whatever input is given to you, the first thing that you should do is you should first sort the array because the order does not matter. And then if you try to see that if we have this array, if we have the sorted version of this array, so it would look something like -4, -4, -2, -1, 6, or whatever the array is. And let's say the element that was left, if you want this to be that element, so that means all of these have to be erased. So when all of these have to be erased, then what will happen is if you erase this one, you have to subtract -4 from everywhere. So that means you will add 4 everywhere, right? So this will become something like whatever the values will become. And then if you want to erase this, you will subtract both of these things to all the other things. So it will cancel out this +4 from everywhere, and this thing will get subtracted everywhere. And then if you want to remove this, so what I'm trying to say is whenever you erase an element, the effect of all the previous elements is same in all of the elements. So it gets totally cancelled out. So if we want this element to be remaining till the last move, so what will happen is that uh, this will get removed, this will get removed, and when this will get removed, we will add 2 everywhere, and that's all that will be left. So the all the effect of these will get cancelled out because this value will be subtracted everywhere, and then when this is subtracted, this is cancelled from everywhere, and then when this is subtracted, this is cancelled from everywhere, and so on. So basically the answer is either the smallest element that is there in the sorted version of the array or the difference between any two consecutive elements. So you can even see it here in some of the samples that here the maximum consecutive difference is 5 because the difference between 2 and 7 is 5 and you cannot get any other consecutive difference. So the answer also is 5, and that's what's happening everywhere. And if there is only one element, then obviously that element has to be the answer. So you can see here the answer is -2 and so on. Okay. Yeah, this one was also easy, but yeah, it's quite interesting, an interesting ad-hoc problem. So in this one, we are given an array of length n, and the elements can either be same or different or anything, and each of the element can be blue or red, and it might be possible that all the elements are blue or all the elements are red, and so on. So in a single step, what you can do is you can take any of the blue elements and you can decrease its value by 1, or you can take any of the red elements and increase its value by 1, and you can do these moves as many times as required. So what you want to do is you want to make this array, you want to convert this array into a permutation. And again, since the order does not matter, so we don't have to care about the order in which the inputs are given. So the input would look something like this. We have 1, 2, 5, 2. This 1 is blue, this 2 is red, and this 5 is blue, and this 2 is red, and so on. So what we can notice is that blue elements we can decrease and red elements we can increase. So it is always beneficial to take all the small elements as blue and all the big elements, like all the small elements we can keep them as blue and all the big elements we can keep them as red. And obviously this will follow because if any red element is smaller than blue element is the correct solution. What we can do is we can increase the red one and we can decrease the blue one. So again, we can come up with a solution like this. So if a solution exists, then definitely a solution like this will also exist. So what we can do is we can just count the total number of blue elements, and let's say if there are k blue elements, so we want 1 till k in blue, and in red we want the element from k plus 1 till n. So first thing that I think we should do here is that we will split all the elements into two groups, the blue group and the red group. Okay, and all the elements in the blue group have to become from 1 till k, and all the elements in the red group have to become k plus 1 to n. And another greedy thing that we can observe here is that if we have some blue elements like say 2, 5, 1, 7, and we have to convert them into 1, 2, 3, 4. So if you want to convert them into 1, 2, 3, 4, it is best to convert this 1 into 1, in this 2 into 2, this 5 into 3, and this 7 into 4. So what we will do is we will sort all of the blue elements. So they will become something like this 1, 2, 5, 7, and we will also sort all of the red elements. And then we want to convert these into like 1, 2, 3, 4, and whatever sorted red elements we have, like maybe 3, 4, 6, 8 or something. So we want to convert them into 5, 6, 7, 8, like this. So to make that possible, all we have to check is that this first element should be greater or equal to 1, second element should be greater or equal to 2, third element should be greater or equal to 3, and fourth element should be greater or equal to 4. And here, first element should be, so first element should be smaller or equal to 5, smaller or equal to 6, smaller or equal to 7, smaller or equal to 8. If all of these are holding true, then it can be done and the answer will be yes, and otherwise the answer will be no. And since we don't have to print the exact the way in which we get the solution, so just yes and no is fine. Okay, this one is actually, I think, kind of a repeat problem, and I'm pretty sure I've seen it somewhere. So in this one, what we want to do is we are given a sequence of LR, LR, and so on. So we want to suggest a starting point so that the maximum number of moves can be performed on the board, and we are also given the dimensions of the board. So, and we want to make sure that the robot does not exit the board, and LURD represent the four directions: left, right, up, and down. So in this one, it's quite obvious actually. You just have to keep track of the maximum left and the maximum right that you have gone, and the maximum down and the maximum up that you have gone. So something like if you have something like L L R L L, so you can see that first we go to 1, then we go like here we go +1, +2, minus again +1, then +2, then +3. So we can see that the maximum right that we have gone till now is just 0, but the maximum left that we have gone is 3. So if the like whatever board length is there in the left right direction, we have to make sure that we do not start in the last three columns. Because otherwise we will go outside. And after this, if there are a few more R's like this, so then from +3 it becomes +2, +1, 0, -1, -2. So this means that the maximum right is also 2. So again, we want to make sure that we don't exceed the right border. So in this way, we just have to keep track of the maximum left that we have got till now, the maximum right. I think I'm confusing left and right here, but you get the idea. So we have to keep track of the maximum up that we have gone, the maximum down, the maximum left, the maximum right, and everything. And in that way, you just have to stay that much distance away from all the borders. So there are 4 borders, and you want to stay that much distance away from all of the 4 borders. But if it is not possible, like if the width is just 5 and you are going 4 in the left direction and 3 in the right direction also, again I'm confusing, 4 in the left direction and 3 in the right direction. So it's not possible to fit this thing anywhere inside the board. So obviously you cannot do this. I think even 4 and 1 cannot be done. So yeah, so you have to make sure that whenever it is not possible to do all the maximum left and maximum right and stay within the board, at that point you have to understand that okay, this is where we have to stop following the instructions, and this is where the robot will break. So you want to find the position in which the robot should be there so that all of these moves can be performed. And that position also can be found out using these only. So if the maximum left is like 2, so we just like if the maximum right is 2, we just have to leave 2 squares on the right so that there is enough space to go 2 squares on the right, and similarly for the top and bottom also. So yeah, so this is the E problem, and F problem is a little bit different. In this one, we are given a grid and there is L, R, U, D, etc. Written in the grid cells only. And what we want to do is we never want to go outside the grid, and we never want to visit a cell that we have already visited. And we want to find the maximum number of moves that you can do. So this is basically nothing but like a graph. It's actually a grid, and let's say if L is written here, so this is pointing towards this thing. So this is just like a graph because all of these cells will act as nodes, and all the instructions that are given left, right, up, down, these are all edges. So we have a graph like this, and we just have to find the longest path in this graph without um, without going over a vertex 2 times. And the good thing is that the out degree of every vertex is just 1. So if there were no cycles, so we know that there can be cycles, right? So I think this example shows us DRLU, so you can see down, right, up, left, and so on. So this is a cycle. If there's a cycle, then that's a problem. But if there is no cycle, then this would be just a directed acyclic graph, and you can simply do DP to find the longest path. This is like the encoder DP contest problem G, in which we have to find the longest path in a directed acyclic graph. That is quite straightforward. But since there are cycles as well, so then what can we do when there is a cycle? So you can notice that whenever you have a cycle, it doesn't matter from where you enter this cycle. Let's say if we enter the cycle from this point, we will go to all of these vertices and come back here, and then the robot will break. So how many vertices are there in this cycle? There are 3 plus 2, 5, and 3, 8 vertices, right? So if there are 8 vertices in this cycle, no matter from which point we enter this cycle, we will definitely go to 8 more vertices, and after that we will stop. So we can take advantage of this fact. So how will we take advantage of this fact? We will find out all the strongly connected components. SCC you can find on cpalgorithms.com. If you want to read about it, you can find it on cpalgorithms.com. So you can find all the strongly connected components and condense them into a single node. So that thing is called a condensation graph. So if you know about it, it is quite simple. All of this is done using the Kosaraju algorithm. If you know about it, then that's great. So you will find the condensation graph, in which what it will do is it will make a single node out of these 8 nodes, and in that place it will just write 8. Sorry. Yeah, so all of those 8 nodes will be packed in a single node, and then just 8 will be written there. So then you will get a directed acyclic graph, because all the cyclic nodes are packed into a single node. So then whatever is left, that would be like a directed acyclic graph. And in this directed acyclic graph, you have to find the longest path. So that is quite simple. All you have to do is you just have to use DP and find the longest path. Some vertices, some of the terminal vertices will have a value bigger than 1 there, because they are formed from multiple nodes. So you have to just add them like this. If we have something like this path is actually 8, 9, 10, and 11. So something like this, you just have to do. The topic that you need to know is just condensation graph. So if you know about it, then this problem is quite simple. Just find all the strongly connected components and then make the condensation graph, and this will be done using the Kosaraju, which you can read about on cpalgorithms. Okay, next one, this one was good. So this is the banquet preparations. Basically, end dishes are given, and each dish consists of AI grams of fish and BI grams of meat. And the total balance is the total meat and minus the total fish and total meat, what are the absolute differences there. And to improve the balance, there's a taster. He's invited, and he will eat exactly m grams of food from each of the dishes. And what he wants to do is he wants to make the balance as small as possible. So he wants to get the values of the fish and the meat almost equal to each other. So what he will do is he can choose how much grams of fish and how much grams of meat he has to eat from a given dish. And since the dishes look like this, so each dish will look like AI and BI, and from this you can eat M. So some amount of A will be subtracted, and the remaining M minus X will be subtracted from B. So in total, if you see what is the effect on the total balance of this thing, so it will be, let's call these xi. So it will be like from each dish, AI is subtracted as xi, and the bi is getting subtracted m minus xi, right? Something like this. So this thing will actually get added, and what you will end up getting is that the original AI minus BI will remain the same, but additionally you are adding m and subtracting 2 times xi. So this will be the effect of doing this. And if you take a summation everywhere, then this thing will remain the same. This m will become n times m because there's m on each of the dishes, and this will become 2 times the summation of xi. So what we want to do is this value we already know, this value we already know. Let's call them capital K, the total sum, and we get k minus 2 times summation of xi, and we want the absolute value of this to be minimum. So we need to know what can be the value of summation xi. So to do this, we want to find xi that is possible in each dish. So in each dish, there is some constraints about how much fish you can eat and how much meat you can eat. Because if you eat a lot of meat, then maybe it is more than m, so you cannot do it. If you eat too few meat, maybe you will have to eat a lot of fish, and that much fish is not available, and that's not possible. So there will be a certain segment Li, Ri type of segment, and this will be the permissible values of xi. So this will be like xi definitely belongs to Li, Ri, and this thing can be found for each I. And then what will be the minimum value of sigma xi? The minimum value of sigma xi will be sigma Li, because the minimum meat that you can eat from each dish that you can find, and you can take the summation. And what will be the maximum? The maximum will be sigma Ri. So this is the minimum and this is the maximum. And since in any of these dishes you can increase the value of xi by 1 very easily, so these values of sigma xi, it can be anywhere between this minimum and maximum. So all of these values are possible. So if I call sigma xi, sigma li as capital X, and this sigma ri as capital Y, then you can then the sigma xi will belong to uh, any value between capital X and capital Y, and you just have to choose the best value. So we just want to choose the best value that will give us the value of k minus 2 times sigma xi as minimum. So to do that, if you can get the value exactly as k by 2, then that's the best thing. But that is not possible, then you will choose whichever value gets you closest to this. So I think after this it is quite simple, and you can do it on your own. I'll just quickly go over the last problem, and then that will be it. So the last problem is kind of similar, but like the setting is a little bit similar, but the problem is totally different. So again, the 10 dishes are there, fish and meat, and now 2 dishes are considered same if the amount of fish and meat are same at the same time. So the variety is the total number of dishes that are there, and you want to decrease the variety. So you want dishes to be redundant. To do it, the taster will eat mi grams of food from each dish. So this time, the m is not same for all the dishes. It is different. Mi is different for each of the dishes, and the taster will determine how much fish and meat he wants to eat, and he wants to eat in total mi grams from that dish. So what he wants to do it he wants to keep the variety as minimum as possible. So one thing that we have to notice is that 2 dishes can be same only if ai equals kj and bi equals bj, right? So bi equals bj and ai equals kj has to be done. And if this is true, then the total weight of the dish, that means the total sum of fish and meat, has to also be same. So whatever input is given, ai plus bi minus mi. So this is the total remaining weight of the dish, and this has to be same. If this is not same, obviously the amount of meat and fish cannot be same, right? So we will make multiple classes, and I don't mean the object-oriented programming classes. I mean the mathematical classes, and like if this value is 5. So if ai plus bi minus mi is 5, then this dish can be equal to only those dishes which also have ai plus bi minus mi equals 5. So we will make separate groups, all the dishes with ai plus bi minus mi equals 5 will be in a single group, and then those who have 7 will be in another group, and so on. So we will have multiple groups, and we want to solve the problem for each group separately. Okay, so let's say we are inside a group. We are inside the group of 5, and we want to solve this problem for those. So here we have multiple dishes that have AI, BI, and MI. And we know that AI plus BI minus MI for all of these is same. So if the total remaining weight of the dish will be same, then obviously if we just get the fish equal, then the meat will automatically be equal because it is just meat plus fish. So if we get the fish equal, then the meat will also be equal. So we have to see after eating MI from this dish, what is the amount of fish that we can have remaining. So maybe we can eat all of the fish and have zero remaining, but in some cases it might not be possible because the total fish can be more than MI. So there will be a lower limit of fish that can be left, and then there will also be a upper limit of fish that can be left, because if we like we cannot leave all of the fish in all cases, because then that means we will have to eat only meat, and what if meat is less than MI, so then that won't be possible. So we know that the fish of I will belong to Li comma Ri, and that will hold true for each of the dishes within this group. Okay, so now what we have to do is we want to have the least variety. So we want to choose the minimum number of points. So basically, we have a lot of segments. Let me take a new page. Uh, it's hanging now. Yeah. So we have a lot of segments Li, comma Ri, and what we want to do is, so we have a lot of segments like this, and what we want to do is we want to take a few points on the line such that there is at least one point inside each segment. So these segments are like this: Li, comma Ri, L1, comma R1, L2, comma R2, L3, comma R3, L4, comma R4, and so on. And at least one point should be there inside all of these segments, right? So at least one point should be there in all of these segments. So these points uh, represent the chosen dishes, right? And if any segment is going over this point, that means that that segment can be made equal to this chosen dish, right? So what we want to do is we want to kind of get the minimum number of chosen dishes. So we want these chosen points to be minimum. So again, we can use a greedy strategy here. This greedy strategy will be something like we sort by the endpoints of these segments, right? So we sort by the endpoints of these segments, and what will happen is we will only choose a dish from the endpoint of a certain segment. So why will we do that? Why will we take only from endpoints, not from somewhere else? So when we move from left to right, let me just make some segments again. So let's say we have some segments like this. Okay. So when we're moving from left to right, we know that there has to be at least one point inside this segment. So where should that be? Here, 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 or here. So we have the maximum advantage of putting it here. Why? Because by the time we put it here, a lot of other segments might have started, and the more number of segments that have started, the better it is for us, because a lot of dishes we are covering in a single point. So when we take this point, both of these dishes get covered. But if we had taken this point, only this dish would have gotten covered, and this would have been left remaining. So that's why we are only picking the endpoints of these. Will this decision be harmful anywhere in the future? It won't be, because when we take this point, all of these segments are gone. And if we had taken anywhere else, maybe some of the segments might have still been remaining, but that won't ever be advantageous, because by putting it more towards the left, you cannot get more segments, because this is the first endpoint. So that means there is no other segment that has ended before that. So we just have to follow this greedy strategy of taking the endpoints successively. First we take this endpoint, and then these two segments are discarded. Then we take the next endpoint, which is this one, and then these three segments are discarded, and then we take this point, and so on. So in this way, in three we can do this, and that's what we have to do in this problem. And that's it for this contest. If anyone has if anyone has a problem with the codes, you can see anybody's submission, because I haven't made any submissions in this contest. So that's it from my side, and thank you for watching. Subscribe to my channel, because I'm going to make a lot more content, and I'll also explain in a later video why I stopped making content for a while and why I'm going to start doing it again. So thank you for watching, and subscribe to the channel if you want to stay.